Hello everyone, welcome you all. Here I am going to discuss the working of jet engine. Jet engine is particularly used in the aircrafts and it's also used in the different applications like missiles and power generation like that. Here I am going to discuss how the working of jet engine is taking place and also the different steps and different types of the jet engines and where this jet engine is used, its applications I am going to take. A jet engine works by drawing air in from the front, compressing, mixing with fuel, and combusted in a combustion chamber, producing hot flue gases that expands through a gas turbine to spin a shaft that powers the compressor and finally exhausting hot gases from back at high speed, generating thrust through the reaction force according to Newton's third law. The engine pushes itself forward by exhaust gas from nozzle as jet at a high velocity. Briefly, we can take as a gas turbine jet engine. That is also called as a gas turbine. A gas turbine jet engine works by compressing air, mixing it with fuel, igniting the mixture, and ejecting the gas behind the engine, creating pushing force known as thrust. And here, the gas turbine, how it works, we know that one. Here, the combustible gas or other fuel will be injected into a combustion chamber where the fuel and the air mixture burns and produces a hot flue gases, and those are expanded in the turbine, producing the shaft power that can be used for the power generation or any other shaft work. Similar to that, here it is working, but it is somewhat different that the power generated by the gas turbine is used for the compressing of the air, incoming air, and those are connected in series. That I am going to take here. Important points to remember for this jet engine. Newton's third law. The principle behind jet engine thrust is based on the Newton's third law, where the force of the hot gas expelled backwards creates an equal and opposite force pushing aircraft forward. We can take example as a aircraft where it is used whenever the burnt flue gases come out from the nozzle and that pushes the forward the aircraft. Turbofan engines. Most modern jet engines are turbofan designs, which have an additional fan at the front that draws in more air. There is an additional fan at the front. Most of the aircraft we have seen, and there it draws the more air and the improving fuel efficiency. Means here if you draw the more air and more compress it, then more fuel we can burn, so that the more power we can generate from the existing that jet engine. Here in the four steps, the this gas turbine or a jet engine works, and those four steps I am going to discuss here. In that first one, air enters the engine through an intake duct. This air is essential for combustion process, and its PD entrance is a crucial first step. Second step is compression. The incoming air is squeezed into a compressor, raising its pressure and temperature suitable for the combustion of the fuel. The compressed air then moves into the combustion chamber, setting the stage for the next step. Next is the combustion. Fuel injectors spray a fine mist of fuel into the compressed air. In the combustion chamber, the mixture ignites, causing increase in temperature and a rapid expansion of gases. The last step is exhaust. These hot gases rush out of the combustion chamber, passing through the turbine. And in the turbine spin by this flow of the gases powers the compressor at the front of the engine. The remaining gas blasts out through the back, propelling the aircraft forward. And here we can see that one. How do engines works? As already we have taken the in the four steps working of the jet engine is taking place. First one is the intake. This is the intake section where the turbofan is used. In the most of the modern uh, aircraft, turbofan is used in which that extract the more air for the flow into the jet engine. And this is the first stage where the sucking of the air is taking place, and that is passes to the next stage as a compression. Here it is a multi-stage compressor. It is air is compressed to its high pressure and temperature. Then high pressure temperature air enters into the combustion chamber, where in the combustion zone. Here the we can see here the we can see the mist of the fuel will be injected into that one. That is a fuel will be sprayed into that combustion chamber, and already the air is at a higher temperature and pressure. That fuel is get ignites and burns, and that due to that the burnt flue gases at a high pressure and high temperature produces, and that will enters into a gas turbine. This is a gas turbine is a multi-stage turbine where the expansion of the gas is taking place, and that produces a rotation of the shaft. Rotary shaft power it will produces, and later this will be exhausted through a exhaust nozzle. And in the exhaust nozzle, the high velocity jet of the flue gases is coming out, and how much speed the gas is having. With the same speed, this jet engine will be move forward, and there the if we connected the this jet engine to the aircraft also moving forward. And here the another thing, the whatever the air is there, that air part of the air will be enters for the combustion. The part of the air through this turbofan will be moving directly out of this one, and that also produces some part of the thrust. And this the burnt flue gases as well as the air what will be moving in the backward direction, that will cause the flow of the movement of the this aircraft in the forward direction. And here we'll take the parts of the jet engine. The parts of the jet engine, first one is a fan or a turbofan, and next comes the two stage, there is a multi-stage compressor. Then comes the combustion chamber where the combustion of the fuel is taking place. Next comes a turbine where the expansion of the that burnt gas is taking place to produce the shaft power, and that shaft powers the this compressor as well as the fan. Here we can see that this shaft is connecting to the till the fan, and therefore that powers it for its working. Okay, therefore that same power is used, and the remaining will be exhausted through the exhaust nozzle. The exhaust nozzle in such a way that arranged in such a way that the flue gases will be come out with a high velocity, and that all the pressure energy is also converted into kinetic energy. Therefore, high velocity jet is coming out, and that pushes the this forward direction. And here we can see that is the working animation. This is the turbofan, and after that, that enters into a multi-stage compressor. Then combustion zone where the combustion of fuel is taking place. Then burnt flue gases will be flow through the this turbine and make that turbine to rotate. That is a expansion of the gases to run the turbine. And the same shaft is connected to the this compressor as well as the turbofan. Here, part of the air is used for the combustion of the fuel, and part of the air is compressed air is directly coming out at a higher velocity. And together, this air and the burnt flue gases together produces a force, that is a thrust, to move this part in the forward direction, and which is connected to the aircraft or a missile that also move in a forward at a higher velocity. At what velocity this flue gases and air are coming out. It is similar example we can see here when the air is filled in the balloon, and when if you leave its mouth, then the air when it come air is come out, the balloon will be move in the forward direction. In what velocity the air is coming out from the balloon, at same velocity the balloon is moving in the forward. With the same concept, this also works, and that is the uh, Newton's third law also. Action and reaction are equal and opposite. Then move further where this jet engine is used. That is the applications of the jet engine. First one is the fighter jets. The fighter jets which are required to move at a higher velocity, higher speed, and there this jet engine is used. And cruise missiles for propelling it, unmanned aerial vehicles, experimental aircraft, rocket engines, guided missiles, hydraulic jet propulsion. Also, we can use electrical power generation, that is also application of the jet engine, powering pumps to run the pumps, drag racers. The drag racers, there is a to move at a higher velocity. Okay, racers. There also we are going to use. These are the different applications of the jet engine. This is working of the jet engine, and this the common thing we might have seen this one in the most of the aircrafts, and this is the jet engine, and that engine that will be powers the its propulsion of the aircraft. And the other type of the engines which are used in the aircrafts as well as in the missiles, those are the ramjet engine and the scramjet engine, which the scramjet is used for the supersonic motion, that is a speed higher than the sound. For that we are going to use the scramjet. And those I am going to discuss in the further sessions. Thanks for watching. If you like, share, subscribe and comment.